It is always good that our dear viewers, you have continued supporting this YouTube channel and the Facebook page. Please, as you'll be watching this video, don't forget to subscribe to our YouTube channel, Zuluba Consultants, and the Facebook page, Zuluba Consultants. We really enjoy the support you are providing to us. And in this video, let us see what we can learn together. In this video, we'll show you how to write the rate law, how to determine the orders of the reactants, how to come up with the overall reaction order, and last but not the least, how to calculate the value of the rate constant. So we have this question. The question reads, given the chemical reaction below and the table of 3 experiments, write the rate law and use the data to determine the orders of all 2 reactants, the overall reaction order, and the value of the rate constant. So we have this reaction here where NH4 plus is reacting with NO2 minus to give us a nitrogen gas and water. So we have the 3 experiments which have been shown on this table. Now this experiment is showing us the initial concentrations of the reactants. So you can see here we have the initial concentrations of NH4 plus in all the 3 experiments. Then this shows us the initial concentration of NO minus in all the 3 experiments. Then the last values are the initial rates for the 3 experiments. So for us to determine the orders of each reactant, we first need to write the rate law. So let's write the rate law for this question. When writing the rate law, you can either use the reactants or the products. But in this video, I'll show you how to write the rate law using the reactants, because they are the ones which we have been given the initial concentration. So basically, if you are writing it against time, you'll say rate is equal to negative the change in concentration of NH4 plus divided by the change in time, or you can say rate is equal to negative the change in concentration of NO2 minus divided by change in time. So when you have this, then you have the rate for these reactants. But basically, this rate can be summarized by putting the constant there, the rate constant. So if we want to summarize this using the rate constant, we can say rate is equal to the rate constant, then the concentration of NH4 plus. This one will be raised to the power n, then also the concentration of NO2 minus raised to the power m. So these powers m and n, they give us the order in which these reactants are in. So if we have this equation, we can use it to determine the orders of each reactant. Now, when you are determining the orders of each reactant, we usually use the values given on the table. So if you look at the table critically, you'll notice that each experiment has the initial concentrations and the initial rate. Now, what is noteworthy is when you look at the initial concentration, take for instance the initial concentration of experiment 1 and experiment 2 with regard to NH4. You'll notice that the initial concentration was maintained, but they changed the initial concentration of NO2. So we can use these two experiments to determine the value of M, because N can easily simplify when it comes to plugging in these values. So let us demonstrate what we mean. So we'll calculate the value of N and the value of M. So let us use experiment 1 and experiment 2 to calculate the value of M. So we have this rate law which we have here. So basically we'll be plugging the values of the concentrations and the initial rate in the equation. So what we will do is we are going to divide a rate for experiment 1 and experiment 2. So we'll say the rate for 2, we'll divide it with the rate for 1. So let us see what are the values for the rate for 2. So the rate for 2, we know that the rate for 2, we have 2.70 times 10 to the power negative 7 is equal to the K value, then the concentration of NH4 is 0.1 m to the power n, then the concentration of NO2 is 0.01 to the power m. So that's the information which we have been given from the experiment 2. So let us divide this with experiment 1. So we say rate for 1. So the initial rate is 1.35 times 10 to the power negative 7. We have the K. The concentration of NH4 is 0.1 m to the power n, open bracket. The concentration of NO2 is 0.005 m to the power m. So at this point, you can notice that some values can simplify here. So this K can go with this K. Then 0.1 m and 0.1 m can also simplify. So this simply means this n and this n will go. So we are simply remaining with these values here and the values this side. So if you divide the values which we have here, 2.7 times 10 to the power negative 7 divided by 1.35 times 10 to the power negative 7, you'll find that this will give you a value of 2.0. Then if you divide 0.1 divide by 0.005, it will also give you 2.0. This will be to the power m. Now, according to the law of indices, we know that if the value has the same bases, then they also correspond with the powers. So this has 2 and also this one has 2 as a base. So this simply means for these to have the same bases, m is equal to 1. When m is equal to 1, then these values are the same. So we have used experiment 2 and experiment 1 to determine the value of m. So we have found that m is equal to 1. So what does this simply tell us? This simply tells us that the rate order for NO2 minus is the first order. So this one is in the first order. So we have the rate order for NO2 minus. For us to determine the value of n, you'll notice that we can use the ratios of experiment 2 and experiment 3. This is because the values of NO2 in experiment 2 and 3, they are the same. So these they can simply simplify. So let's use these two concentrations and the initial rate to determine the value of n. So basically we'll divide the rate for experiment 3 with the rate for experiment 2. So for experiment 2 and experiment 3, the initial rate for experiment 3 we have is 5.4 times 10 to the power negative 7. When you divide it with the initial rate for experiment 2, which is 2.7 times 10 to the power negative 7, so this is equal to K. The initial concentration of NH4 with regard to experiment 3 is 0.2. This will be to the power n. Then the initial concentration of NO with regard to experiment 3 is 0.1 to the power m. So we divide this with K. The initial concentration of NH4 with regard to experiment 2 is 0.1 to the power n, open bracket. For NO3 is 0.01. So even here it's 0.01 to the power m. So already you can notice something, that these two values, they can simplify. The K value and this K value will simplify. So if you divide these, which we have here, 5.4 times 10 to the power 7 divided by 2.7 times 10 to the power 7, we'll have 2 is equal to, if you divide these values which are here, we'll have 0.2 divided by 0.1. The answer which we will get is 2. This is to the power n. So again, using the law of indices, this simply tells us n is equal to 1. So what does this simply tell us? So it also tells us that the order for HO4 plus is in the first order. So we now have the two orders, the value for m and the value for n. So let us now show how to calculate the overall order. Get the overall reaction order, we basically add the powers which we have found. So we are saying we calculated for m and n, then we found that m is equal to 1 and n is equal to 1. So what does this simply mean? We say 1 plus 1 is giving us 2. So what does this tell us? This simply tells us that the overall reaction or the overall reaction order is in the second order. So the overall reaction order is in the second order. So that's the overall reaction order. So now that we have this overall reaction order, we can write the rate law acknowledging the values of the individual rate order. So here we'll say rate is equal to the K value, the concentration of NH4 plus. So this is to the power 1, so we are not going to show the power there. Then also the for NO minus, also to the power 1. So this becomes the overall rate reaction or a rate equation. So we can use this now to determine the value of K. So basically, for you to determine the value of K, with this equation which we now have, you can pick any of the experiments, either experiment 1, experiment 2, or experiment 3, to determine the value of K. We have that expression there. Now we can use the values of the first experiment to calculate the value of K. So the initial rate for the first experiment, we know that it is 1.35 times 10 to the power negative 7 is equal to K. Then the concentration of NH4 in the initial experiment, or rather in the first experiment, is 0.1 multiplied by the concentration of NO2 in the first experiment, which is 0.005. So once we have this, we can make K the subject of the formula. So when we make K the subject of the formula, we'll say K is equal to 1.35 times 10 to the power negative 7. So if we put the units, it is moles per liter second divided by the concentrations, which is 0.1. This is mole per liter. Then also 0.005 moles per liter. So with the knowledge which you have in dimension analysis, you can simply see that something will happen here. That is, these units and these, they will simplify. So the answer will have a liter, mole, and second. So what will be the answer then? So the K, if you divide these values, it will give you 2.7 times 10 to the power negative 4. So this liter, which is here, will now become the numerator. So liters per mole second. So this becomes the K value. So you can try to use experiment 2 and experiment 3 to see if you get the same value as the K value. And please look at the dimension analysis, because in some questions they can ask you to state the units for the K value. So hope you have seen this video, and in summary, we use the experiments to determine the orders and the overall order. Thereafter, we can use one of the experiment to determine the K value. We hope that you enjoyed this video, and please don't forget to subscribe to the YouTube channel, that is Zuluba Consultants, and click the notification bell so that every time we post the video, you are able to see that we have posted the video. Not only that, you can also follow us on Facebook, Zuluba Consultants, for this and more videos.